You're good.
Rube Goldberg, take 3.5. Flame isn't over.
There we go, it's burning.
Okay, go. Go outside so you can see me.
Come on, call. Where's it going?
Hurry up now, any day.
Yes, oh my god.
It's going.
Please.
Go. Oh crap, it's good. Should I knock it?
Yeah, just knock it.
Oh my god! Yeah!
Okay.
This is a chemical reaction. We didn't show it, but it happens. So everything just went in. For our Rube Goldberg machine, we start out with this being pulled, which is potential to kinetic. This string is elastic potential, so it's elastic potential to kinetic. There's going to be a ball right here, which is gravitational potential to kinetic when it's being pulled down. It's going to roll down the ramp. It's going to hit this cart, which is kinetic, which this is going to be lit. So it's kinetic to thermal. When it hits the string, it's going to burn the string, which will have the rice bag right here, and it's going to land on the stylus and call the phone that's over here. This curling iron is going to be connected pre-filmed, and it burns through the plastic container because it's the thermal energy is transferring through the container and burning it. And then the phone is going to ring, and when it vibrates, it's going to come over here and knock over into the baking soda, or the vinegar. So the baking soda is going to knock over into the vinegar, which is going to be the chemical reaction, and it overflows. Oh, and this is when the phone rings, it's electromagnetic. It overflows and it's going to hit the dominoes down, and then it's going to knock the golf ball down, and then it's going to knock all these dominoes straight down. And this is going to roll down here, which is gravitational potential to kinetic when the dominoes are being knocked down. When the line falls, it's gravitational potential to kinetic. It's going to hit the keyboard while it's rolling down the ramp, which is gravitational potential to kinetic. When it hits the keyboard, the computer is going to turn on, which is electromagnetic. It's going to roll down. It's going to hit this ball that makes sound whenever it's hit, so that's kinetic to sound. This sound ball is going to hit these dominoes, which is gravitational potential to kinetic, because when they fall, they hit the mousetrap. The mousetrap is elastic potential energy, and it's elastic potential to kinetic when it goes off. When it goes off, it's going to release this chopstick that will release this sandwich maker to close. When it closes, the hair dryer is going to be turned on, which this is gravitational potential to kinetic when it closes. It is going to be turned on with this reset button. This mousetrap is going to be set up at the end, so when it closes, it's going to go off, which is elastic potential to kinetic. This is going to be turned on, and the blow dryer is right here, so it's going to turn on and knock the book over, which has this sound bell. So when it falls, it's going to knock over and hit the floor, which is going to create the sound. This book is going to be gravitational potential to kinetic. When it falls, it's going to knock down this book over here, which is going to have Alka-Seltzer at the end of the book. So when it falls over, it's going to land into this bowl of water and cause a chemical reaction. This is going to fall onto the string and turn on the light. This is also electric energy. I forgot to mention that. And when the light turns on, we're considering that our electric energy.